4.9 Quadratic Systems. We've already done a lot of problems like this, so get out Desmos and let's graph away. Problem 1, x squared minus 2x. Okay, we're just going to enter this in Desmos. So we see a parabola, and the other one should be a line. So look for where they cross. Simple enough. They cross at 2 points, 0, 1, and 4, 9. So solve each system. Number 3 is pretty much the same thing. You've got a negative x plus 2x plus 10. And y equals x plus 4. All right, pretty much the same thing, a parabola and a line. You got 2 points, negative 2, 2, and 3, 7. Next one's going to be a little more complicated. Got negative 7x squared minus 9x plus 6. And we can do a fraction, 1/2 plus 11. All right, this one's weird because they don't cross, and that's okay. When the two things don't cross, when the two graphs don't cross, we would say no solution. There is no point in common. There is no intersection. So no solution. It wouldn't hurt if you actually drew what it looked like. Number 7, see another line and a parabola. So I'm going to switch these two around since I've already got the parabola up here. X squared minus 8x minus 9. That's the bottom one. And then the top equation said x plus y equals 3. All right, so zoom a little bit. We see two solutions. And they're messy decimals, but that's okay. Just write down what you see. They've rounded. Desmos has rounded off to 3 decimals. That's what we'll do as well. Negative 1.424, comma 4.424, and 8.424, comma negative 5.424. So if it looks complicated, that's okay. Don't worry about it. Now we're going to solve the system by graphing. You should be able to tell that these are going to be parabolas. You're going to have a dotted parabola that opens down, and the less than means we shade down. And then greater than means it's a dotted parabola that opens up, and we're going to shade up. So that's kind of what it looks like, but let Desmos do it. So y is less than, we'd have negative 3x squared plus 1. And then the other one, y is greater than x squared minus x minus 5. All right. So that's what it looks like. One thing you can do if you want is change them to the same color. I think that makes it a little bit easier to see the overlap. We're looking at the overlap or the region that's been shaded twice. So we're looking right here. You can ignore this and this. We want to color in this. But the hard part, I think, is nailing down how to graph this or where they are. So you really want to look at some specific points. So if we're graphing this one, I see a vertex is at 0, 1. All right, so this is kind of hard to do because the graphs are too small. But we have a vertex at 0, 1. And then notice the negative 3 makes your 1, 3, 5 into a times 3 is going to be a 3, oh my gosh, 3, 9, 15. So basically what we would do is we would go down 3, 1, 2, 3, and over. And then if we had room, we'd go down 9, but I don't really care to do that. So let's just draw a dotted line, or a dotted parabola, I should say. And we know we're going to shade down from there, but let's hold off on that and let's do the other one. Okay, the other one has a vertex of 0.5, negative 5.25. 0.5, negative 5.25 is going to be really hard to draw, but just, kind of eyeball it up. Here's 0.5, and then 1, 2, 3, 4, 5.25. It's got to be about right there. Okay, so we're going to put a dot about right there. Okay, and then, what you can do is kind of look for points. There's one, 0, negative 5. So I don't know, 0, 5, can't get that point. And 1, negative 5, so that helps. 0, 5, and 1, negative 5. Oh, sorry. All right. Let's see if we can't find another one. No, that's hard. Let's just do this. Negative 1.7 and positive 2.7. We can estimate that. Negative 1.7 and positive 2.7. Negative 1.7 and positive 2.7. Okay, that's probably going to be good enough. So let's draw a dotted line. Or a dotted parabola. And shade the region we're supposed to. So that region, again, this is going to be hard to do because it's so small, but do your best to color inside that region right there. We're drawing a picture of the solution to this system of equations. All of those points are solutions. So it says, then name one point in the solution set. So a lot of the times I would start by looking at 0, 0. Is 0, 0 a solution? Well, in this case, yep, it sure is. So that's one of those solutions. So then we just do the same thing. Less than, you can type in less than equals, and it was x squared minus 1 and greater than 3x squared minus 3. Okay, so that's an interesting one. X squared minus 1. X squared minus 1 is this one. Notice we've got those 3 points. Okay. So we've got 0, negative 1. Here. And I notice that that's going to be a solid parabola, and I'm going to shade down. Okay. It's got a 1, 3, 5 pattern, so I can go 3. I could go up 5 if I wanted. But I've got a pretty good looking, or a pretty good idea of what that looks like right there. Solid, and I'm going to shade down. Now the other one, if you look at the other one, it's got a vertex at 0, negative 3, and it hits those same 2 points right there. So 0, negative 3. And then these points, because it's got, instead of a 1, 3, 5 pattern, it's got the 3, 9, 15. So really, I could go up 9 now. 1, 2, 3, 4, 5, 6, 7, 8, 9. And get points right there and there. So that's going to be a dotted parabola. Again, pretty hard to do. But I want to be greater than the blue one and less than the red one. that means I'm shading in this region. Wish I had given you better graph paper, but let's look over at Desmos for picking a solution. If you want to pick a solution, 0, 0 is not in the double shaded region, but this point is. That's 0, -2. So let's list that as our point. 0, -2.